Alright, ladies and gentlemen, this is going to be a continuation on the video on energy and enzymes. So let's get started on this next video. So remember the collision theory. All chemical reactions are molecules going through and colliding, and they have to collide at the right orientation for a chemical reaction to occur. That's how we get the products in our chemical reactions. This will occur naturally, but all an enzyme is going to do is speed up that process. So an enzyme is lowering the activation energy and increasing the probability of a chemical reaction to occur, thus speeding up the reaction. So let's think about this a little bit more. All the enzyme is doing is ensuring that the chemical reaction occurs at a faster speed. So those molecules will eventually collide into each other and go through a chemical reaction. But if I place the enzymes in the actual reactant itself, well, now I'm going to get the reaction when I need it, so that way I can maintain homeostasis. Now, if we think about this some more, again, they're lowering the activation energy. Instead of relying on the energy for the molecules to collide, I'm using the energy that the enzymes have to go through, lower that activation energy, and therefore get the reaction to occur more efficiently. So when we're thinking about this, remember, it's a probability thing. We're going through. By placing the enzymes in the actual chemical reaction, I'm getting the reaction to occur faster, and I'm lowering the energy that is needed to break or put the molecules together because I'm using those enzymes. And it all has to do with interacting with stimuli and making sure that we're maintaining homeostasis. So we can see here that the activation energy is significantly lower than the energy that would be required if the enzyme was not present. So there's two things I also want to think about. We have two types of enzymes here. Now, the first type of enzyme that we have, well, these are going to be synthesis enzymes, ones that bring molecules and put them together. So in this case, an example, we're going to have two molecules, and this enzyme is going to go through, bind in the active site. We're going to take the substrate, we're going to go through a conformational change, and then we're going to be going through and putting that molecule together. We also have enzymes that will break down molecules. They will take a molecule, break it apart, maybe they need to release energy, or they need it in smaller components. So again, there's two ways that the enzymes can go through and get the chemical reaction to occur. They can do it by putting bonds together, putting molecules or atoms together, or going through and breaking them down to release energy, or to go through and break them down into smaller parts. Now, if we continue upon this, we can also control enzymes a little more efficiently in our body. So remember, normally we have our substrate. It will go through, the enzyme will allow it to bind into the active site, lowering the activation energy, getting the chemical reaction to occur faster. Our products will be produced. And in this specific case, we had the enzyme produce the products that were necessary for whatever chemical reaction we needed in our body. Now, let's say we didn't want this chemical reaction to occur in our body for some reason. Well, in this case, what your body will release, or what we're going to put in the system, is we're going to put an inhibitor. Now, this inhibitor is going to cause a change in the shape of the enzyme. It's going to block the active site, or change or make the active site smaller, or change the intermolecular forces in the active site. So now the substrate can no longer bind. If the substrate can no longer bind, then in this specific case, what we're going to get is no chemical reaction. So all an inhibitor is a substance which slows down or prevents a particular chemical reaction or other process which reduces the activity of a particular reactant, catalyst, or enzyme. In this case, we just want the enzyme to no longer function for whatever purpose in our body. So let's go through and look at enzymes and make sure that we understand enzymes comprehensively. So remember, based on the video, enzymes' purpose is to speed up a chemical reaction. It can also slow down a chemical reaction if our body needs to. So the way that we're going through and speeding up that chemical reaction is utilizing enzymes because it's a catalyst. So if we continue here, they're lowering the activation energy, increasing the probability, and ensuring that the molecules go through and break apart. Without an enzyme, this is what the curve would look like, and with an enzyme on the right-hand side, this is what the curve would look like. Now, if we want to slow a chemical reaction, enzymes will have inhibitors which are released by the body that block enzyme activity. And they're going to go through and slow the reaction because the enzymes will not be able to take in the substrate. Now, enzymes depend on optimal conditions, optimal pH, optimal temperature. Without those, the enzymes will go through and denature. When an enzyme's denature, that's going to be problematic because you can no longer maintain homeostasis, and you can no longer go through and get the necessary chemical reactions that you need for your body. So did you guys learn? Well, did you guys review enzymes' purpose here and really comprehensively try to understand the big picture and what their purpose is? Did you guys go through and think about the two types of enzymes that build and synthesize things, and then enzymes that break them apart? Did you guys go through and figure out how to increase chemical reactions with enzymes? And do we understand how inhibitors play a role in decreasing chemical reaction speed if needed in the human body? This is going to be the end of the video. I will see you guys in class tomorrow.